Hi, this is a podcast on KSP solubility products like we've worked on before, but today's podcast is specifically on solving common ion problems. Now, to be comfortable with this and understand what it is, first of all, a common ion problem involves exactly what we did the last time with regular KSP problems. There are ionic salts that do not dissolve well, but now I'm going to add a step, and then we're going to combine these ionic salts that don't dissolve well with an ionic solid or a salt that completely dissolves. Okay, so that's the difference. It's a KSP problem that's a salt that doesn't dissolve well, and we're going to add a salt that does. So let's just rewind real quick. What does KSP mean? That means it's solubility product constant, and that means that every single item that's on this chart, and there's other charts, is a poor dissolver. It's very bad at dissociating. Okay, dissociating is our fancy word for dissolving. It's bad at dissociating. I'm going to call it a dissociator or a bad dissolver. I know it's not a word, but I don't care. Okay? So I care, but I care that you understand this. So if you look at this, why are these poor dissociators? Why do they have a hard time dissolving or dissociating? Well, this right here, if you talk about KSP, remember, is products to reactants. And the smaller our K is, the smaller our equilibrium constant, that means I have way more reactants. 10 to the minus 8th right here, 10 to the minus 12th, 10 to the minus 29th. That means that this is a poor dissolver. This is worse, right? And this is super bad at dissolving or dissociating. Okay, so that's what those mean. If you're on the KSP chart, that means that I have a hard time dissolving or dissociating. So, again, we need to know how to do dissociation equations. So let's just go ahead and take silver bromide on here, right? That's a poor dissolver, 7.70 times 10 to the negative 13th. And to write a dissociation equation, I take AgBr, double arrow, it's a solid. It's landing on this chart. I know it's like at a KSP value, therefore I have a double arrow. I'm going to go ahead and dissociate it into the two ions that it forms. I'm running equilibrium directions. Sorry. Okay, there you go. Sorry, I'm racing to get this done, guys. My bad. So here we go. I've got silver, and I've got bromide ions, and they're aqueous.